Okay, so this is a continuation of what we started. Right. This is Navier Stokes equation. Right. This is the Navier Stokes equation we started in our previous class. It is basically the analogous of Newton's second law. That is F is equal to dp by dt, where P stands for the change in momentum. Now this is what we are doing in the case of fluids. हम लोग solid mechanics से we are going into fluid mechanics. So the changes that we encounter while going into the fluid mechanics is, first of all, there is a shift in what? Frame of reference. Frame of reference. Look, Lagrangian से Euler frame of reference में जा रहे हैं. Lagrangian to Euler. What is the difference between these two? The Lagrangian frame of reference, it particularly focuses on a particular particle. Right. So it is based upon the initial state of the particle. That means मुझको अगर R मालूम करना है, the position vector of a particle, then it will be equal to initial state of the particle plus what the particle has moved in time t. ठीक है, एक पार्टिकल कितना मूव किया है इन टाइम t. R0 plus 0 to t this is valid for Lagrangian. एक पर्टिकुलर पार्टिकल को हम लोग फोकस कर रहे हैं, वो कैसे मूव कर रहा है, and this is supposed to be the initial state, but we do not follow this frame of reference in fluid mechanics. जब हम Navier Stokes equations के बारे में पढ़ रहे हैं, we follow the Euler concept, Eulerian frame of reference, जहाँ पे there are a set of points in space. Set of points in space, and we actually keep a track of the fluid passing through those points. इसका मतलब है only the velocity से position vector r and t के वजह बनते हैं, not the initial set of points it has moved, right? So this is the difference between these two frames of reference. So based upon the Newton's second law, so F is equal to NA, and say you can say F is equal to NA, Newton's second law. लेकिन in the case of Navier Stokes equation, the only difference is that this F is now summation, not a single F, right? और इस summation of F में क्या क्या आता है? एक आता है gravity या V plus viscosity और एक आता है pressure या less plus some miscellaneous forces, outside forces. So basically these three forces are there. ठीक है ना? इसमें this pressure force का एक coupling component होता है. What is a pressure? Pressure is a normal force. और एक ऐसे हम लोग normal force देंगे तो उसका एक reaction force होगा. So there will be a coupling. Couple components इसके होंगे दो. Couple coupled components for pressure is 2 in each direction. Again, in the case of viscous force, that is, we are talking about shear force. Viscous is shear force. Viscosity, right? Tau is equal to eta du by dx. Shear force. Shear force में क्या होता है? There are 3 components. Okay, in each direction. 3 components, coupling components. What is a couple? Equal and opposite forces. Equal and opposite forces are called couple. So इसके 3 component in every direction. So total number of components is 3 into 3, 9. Did you understand this? That means कौन से components के बारे में बात करते हैं? What do you know? ये दो. इसके अलावा
सिग्मा एक्स सिग्मा वाई
और टाउ है उसके बाद में सिग्मा नंबर बिकॉज़ आई एम टॉकिंग अबाउट शेयर इसलिए मैंने उसको टाउ लिखा है बेसिकली दे आर द सिग्मास इफ यू कंसीडर दैट टू बी अ मैट्रिक्स अगर तुम इसको मैट्रिक्स कंसीडर करो सो द प्रिंसिपल कंपोनेंट ऑफ मैट्रिक्स x y y z
एक्स वाई
x y z तो इसका corresponding यहाँ पे y x
वाई जेड
zx these are the principal components और these two are the couples ये दो couple है ये दो couple है और ये दो so these are the couples ठीक है so one is the pressure force PRS एक gravitation force और दूसरा है viscous force C तब लोगों ने यहाँ तक we finished in our previous class we have said that the pressure force is nothing but dP by or rather dP by dx dP minus dP by dy minus dP by dz से इसको एक साथ हम लोग लिख सकते हैं ऐसे del P so this quantity minus del P है ना अच्छा we derived this part हम लोगों ने ये वाला पार्ट डिराइव किया था कैसे डिराइव किया था याद है we have introduced a special derivative instead of dP by dt we are considering here d capital dP by dt okay so capital dP by dt to consider एक extra term यहाँ पे आ जाता है that is b dot del v we have derived it in details and this is the miscellaneous force this is pressure force only thing that was left was or tau xy is equal to tau yx is equal to mu xy plus yx this we have derived previously कौन थे class में you were there हाँ तुम लोग so what is this ये जो quantity है ये है strain rate that means liquid flow में whenever a liquid is flowing the difference liquid flow with a solid is that उसमें कोई shearing force नहीं होता that's what it flows there is no resistance to a shear force so that means there is no strain strain मतलब change in dimension divided by original dimension तो यहाँ पे तो चेंज इन डायमेंशन इज इनफाइनाइट, आई मीन इट इज कीपिंग ऑन इंक्रीजिंग, मतलब कोई रेजिस्टेंस नहीं हो रहा है. You cannot say that delta L इतना change हुआ है length में due to the viscosity, right? So the strain is infinite. What is finite is the strain rate, the rate at which it is changing. So इसी strain rate को with respect to the shear force equate किया गया है. और यहाँ पे जैसे in the case of solid mechanics you have the modulus, in the case of fluids you have the viscosity, है ना? Viscosity, coefficient of viscosity. Now strain rate मतलब क्या? What is strain? This I can write ये जो quantity है ना, x y ऊपर dot है मतलब it is with respect to time differentiation हुआ है. So I can write this one as what? As T of dy by dx I can write it this way. Dot मतलब with respect to time, differentiation with respect to time, that is v f equal to p dot. ठीक है. So what is this? यहाँ पे समझिए वो क्या है x y. What is x y? हाँ ना this ये थोड़ा सा you need to understand this, right? अच्छा, let's move to the case where a strain is being applied. Poisson's ratio जानते हो किसको बोलते हैं? What is Poisson's ratio? हाँ, so what is that? Sigma yx by sigma x. ठीक है ना? तो मैं अगर if I am applying stress in any particular direction, okay, उसका corresponding उसके दूसरे directions पे क्या होगा? That is the Poisson's ratio. ठीक है ना? That means if I am applying stress, this is a tensor quantity. इसके 9 components हैं 1, 2, 3, 4, 5, 6, 7, 8, 9. ठीक है? This is being equated to equal to modulus plus strain के भी components होंगे 9 components. ठीक है? ये वाला जो diagonal है this is the principal strain sigma epsilon. ये वाले जो components हैं ये क्या denote करते हैं? Even if I am applying the force on the x-axis, the stress has been applied on the x-axis, उसका effect on the y-axis. So this is the ratio of that is the Poisson's ratio. ठीक है? तो वही हो रहा है कि ये तो हो गया this part d by dt. दूसरा जो part है ये जो part है this tau x y is equal to mu the rate of change, rate of strain rate either in the x direction due to y or in the y direction due to x. इसी को मैं लिख सकता हूँ एक कंपोनेंट को मैं लिख सकता हूँ x by dt into dy by dx. So this becomes dx dy by dx. इसी तरह से dy by dx. So if you add all the taus, you get the values mu sigma square v. है ना? ये Now you differentiate with respect to this, you will get this one. Okay? So that's how you get the final value. Okay. Abhi, let us move back to the control volume. ये कंट्रोल वॉल्यूम ये मैंने लास्ट क्लास में एक्सप्लेन किया था. दिस इज द कंट्रोल वॉल्यूम यहाँ पे. So a momentum which is coming in a certain direction, after it is getting past the control volume, it is changing like this. ये जो dv by dt वाला है, dp by dt, capital dp by dt, जो मैंने अभी लास्ट क्लास में लास्ट स्लाइड पे कहा था, उसी का the effect of that is see mv, it is getting converted into mv plus d by dz mv dz, and same is the case for all the other three. So this is the control volume. Control volume is where the actually the changes are taking place. So control volume का जो application है वो है in the case of submarines. ठीक है. In submarine में देखो, submarine needs to be moved through the water. It needs to be the forces that is acting on the submarine are drag, lift and pressure distribution. Drag मतलब it is not, it is moving in the जब cycle जब चलाते हो there is a curved road, so there is a air drag, उसी तरह से drag, right? Lift is where it is being getting lifted from below the ocean to above the ocean. Or pressure distribution is the reason why these torpedoes are being sent. ठीक है. So देखो ये जो बीच वाला जो रीजन है, this is the control volume. So whenever it is throwing out water and taking water. जब ये भर जाता है, so due to the pressure it is moving up, है ना? Can you see? ये वाला जो अंदर है, this is CB, control volume. जैसे प्रेशर भर जाता है, it is moving up, और जैसे ही वो छोड़ देता है, then it is coming down. So these are the three different aspects of control volume being used in submarine for different reasons. Right?
So ये नीचे में क्या हो रहा है?
ये तो ट्रैपिडोज है ना, ट्रैपिडो. ये actually it is the drag.
ये जो पनडुब्बी है.
हाँ, ये डूब गया है. Then it has to, ये वाला है, this is ट्रैपिडोज. Vorticity, जो asked in the first class, what is the vorticity? ठीक है ना? So this is the torpedoes being sent.
वो पहले ऊपर जा रहा है. ये कंट्रोल आप.
कौन सा?
नीचे वाला.
अच्छा नीचे ये वाला. हाँ.
तो इसमें फेनोमेनन क्या हो रहा है?
प्रेशर डिस्ट्रीब्यूशन में चेंज हो रहा है एंड ड्रैग, ये लिफ्ट हो रहा है. दिस इज लिफ्टिंग एंड चेंजिंग प्रेशर. That is how the torpedoes are being sent. ये is actually not as simple as it looks. बहुत सारे इसमें equations हैं. Just to make you understand the effect of control volume, I downloaded this from the net.
And ऊपर में वो पहले पानी खाली था, फिर
हाँ.
पानी उसमें भर गया,
हाँ.
वो नीचे आ गया.
So this is the control volume.
और सारे सबमरीन में वो होता है.
हाँ, एक there is a chamber जिसमें कि control volume होता है. उसके in and out of water से it actually controls the drag, lift.
जब ऊपर आना होता है तब वो
हाँ,
पानी को
छोड़ देता है, रिलीज कर देता है. प्रेशर डिस्ट्रीब्यूशन ऐसा. ठीक है. ओके. So I think we are done with this one. Let us move on to the next topic of today's discussion. Goals. We need to go to home. Right. क्या हो गया?
कंप्लेन कर रही हूँ.
Thank God. So today we start a new topic that is called dimension analysis. ये तुम लोगों ने किया होगा I think plus 2 में. Same thing. Now dimension analysis is important in every mechanics, not only fluid mechanics. So we shall be applying this to this dimension analysis. Now dimension analysis, you know, we divide a physical quantity into M, L and T. और इसके पीछे there is a law. It says that in an expression deduced for a given physical quantity, the dimensions on both the sides must be same. Right? इसको बोलते हैं principle of homogeneity of dimension. So now fluid mechanics में जो physical quantities हम लोग use करते हैं, we will first of all उसके dimensions को हम लोग find out करेंगे. And then we will use it to find the relationship between them in different physical cases. Okay. Is it first of all, what should be this symbol? इसका मतलब whenever I am putting a third bracket, what I am trying to say is that इसका मतलब है what is the dimension of this? Say velocity का मैं अगर बोलता हूँ velocity putting a third bracket, so it means it is equal to L T minus 1. तो थर्ड ब्रैकेट का सिंबल याद रखना. विस्कोसिटी का क्या होगा डायमेंशन? फर्स्ट ऑफ ऑल विस्कोसिटी के डायमेंशन को जानने के लिए यू नीड टू सी द रिलेशनशिप ऑफ विस्कोसिटी वर्सेस द शेयर. कौन सा रिलेशनशिप है याद है? अभी तो मैंने डिस्कस किया था. हाँ, विस्कोसिटी का रिलेशन विद रिस्पेक्ट टू शेयर. हाँ, टाउ इज इक्वल टू बीटा एक्स डी बाई डी एक्स. ठीक है. व्हाट इज टाउ? shear stress, that is force by area. Force by area. ठीक है. अभी find out what should be the value of this